Okay, so I just want to welcome everybody. My name is Silvio Perez. I am the Simulation Product Specialist for Hawkridge Systems. So I focus on a lot of the pre-sales and training for anything simulation, whether it be our structural tools, our flow simulation tools, or our injection mold analysis. So the topic for today's webinar Wednesday is from SOLIDWORks CAD model to a simulation mesh, a look into prepping your model for a simulation study. So I created this topic here because, like I mentioned, a lot of what I do is simulation training, and if you've gone through simulation training or gone through the material, the manual that we provide doesn't specifically go into how to simplify a model, or you have your final design, how can you clean up that model a little bit so you can prep it for a simulation study. So a lot of the topics that we're going to go into, when I initially created this, my focus was structural analysis, but I ended up finding, or kind of noticing that, a lot of these topics or a lot of these things that I'm going to present are going to overlap if you have flow simulation as well, a CFD tool. So it's just a way for you to, what you see on your screen, to get something, an elaborate design, to a point where you have a model that's still usable, right? Usable and still able to get results or accurate results in a simplified manner there, right? So that's really what the goal for today is, what we're going to discuss. Just to show you exactly what we're going to get into, this is today's agenda here, right? So we're going to get into a few things. We're going to get into, well, why do I even want to simplify my model, right? I'm going to go into a few specific things as far as, why that's important. Why can't we just run simulation on our final design? Talk about a system option that may affect, the quality of your model, or being able to visually see if there's any issues with your model. And then going into utilizing configurations for parts and assemblies, being able to create them and link them to different versions of your model. And then actually go into, a couple of key points, or a couple of examples as far as simplifying a part, and then graduating into assembly as well. And then closing it off with some overall general tips as far as what to look out for, pretty much an overview of what I'll be discussing today. So the first thing that we have here is, why do I want to simplify my model for simulation? All right, so there's a lot of good reasons here, and these are kind of my top 4. But simulation doesn't really require a high level of detail to get accurate answers, right? When we run simulation studies, that's what we want. We want to make sure that we are attaining or getting the correct answer, the most accurate answers, but we don't necessarily need to, you spent so many hours on that final design, adding that level of detail in the actual CAD model. A lot of those elements that you apply to the model are not necessarily needed in simulation, and sometimes may make the simulation process a little bit more difficult. So at the end of the day, it just makes your life a little bit easier, right? And it makes your life a little bit easier in the sense that in a simplified case, you have a better chance of meshing the model successfully. So, currently, like I mentioned, I do a lot of training, I do a lot of pre-sales, but my background, or when I started at Hawkridge, was a lot of technical support, specifically simulation technical support. And there are tons of cases that I can discuss here or kind of bring up that pertain to what I'm talking about today, which is, one of the common questions, or one of the common issues that I get is, my part won't mesh, or my assembly won't mesh. And of course, there's a number of different reasons why a part or an assembly won't mesh, but a lot of the times is, the level of detail that's inside the model is just too much to account for what the appropriate element size should be. So ultimately, the more simplified it is, the easier it is the mesher is going to have to actually mesh the part or assembly. Right? And then in doing so, again, related to technical support and troubleshooting issues as well, of course, having a more simplified model, simplified part or assembly, will make troubleshooting sim issues a lot easier in the long run. Right? So the more detail you have in your model, the more time is going to take to kind of filter out what the root cause of the issue is of meshing your part, or maybe even running the analysis. Right? Maybe there's just the level of detail is so complex that we're not able to account for. We're not going to be able to account for all the components that are there, and at the end of the day, we may not even need any of those components or a lot of the components. Right? So that being said, meshing your part or assembly on a simplified model eventually could decrease the runtime. And that's always an issue as well, right? We always want to get those accurate results, but we want it, right now, right? So the more detail there is in your model, the more mesh elements there potentially is going to be, therefore the more calculation that needs to be run. So if we have a simplified case, the mesh is going to be more simplified and therefore potentially affect the runtime in a positive way, pretty much decreasing the runtime. Okay, so these are some of the reasons why we would want to simplify a model. What you're seeing on screen, though, that image that I pulled up, what I'm going to be talking about is more geometric simplification, cleaning up your model a little bit, using some SOLIDWORKS features. But ultimately, what the direction that you have to take in terms of simplifying your geometry, simplifying your assembly, really depends on answering the question of what exactly am I trying to extract from my analysis? What am I trying to learn from my study? So when you answer that question, that could filter out a lot of components that are just not necessary within your assembly. Right? And what you see here is, maybe you're trying to run an analysis on an L bracket. In real life, that L bracket is attached to a block that eventually is attached to that bar. Right? If I'm only really concerned about the stresses that are happening in that corner, do I really need all the other components? Right? Because there are ways within simulation where we can, represent bolts with restraints or fixtures, and eventually we can simplify to the point where we just end up with that L bracket and really just run the analysis on what we care about. Right? So that's another level of simplification. There is such a thing of oversimplifying, right? If we were going to look at this case again, the overall results that we get from this scenario versus just the L bracket, we are going to get different results. But ultimately, it comes down to what exactly are we trying to learn from this analysis? What is our main concern? Right? So kind of answering that question will guide us in the way we want to simplify our model or our part or assembly. Right? So the first thing that I want to get into in terms of before manipulating the model or cleaning up the model, there are some system options or a system option to be aware of that directly relates or could affect the quality of your geometry. Right? And it's this one thing called verification on rebuild. It's found in tools, options, and then in the performance section, and it's the first option that you see here. Upon a fresh install of SOLIDWORKS, that option is actually off. It's off by default because it is a performance feature, meaning that if you do have it on, to a certain extent, it may affect the performance. Why? Well, let's contrast that with just a regular rebuild, right? So, well, before we get into that, the reason or what that verification on rebuild does, it's an option to run an advanced body check on the bodies and faces of your parts in assembly, right? So it's checking the quality of every component of the assembly, and the way you kind of activate that or you run that check is running this Control Q, hitting it on your keyboard, and that's what does what's called a forced rebuild. So how does that contrast with just a normal rebuild? Control B. So you may have noted or you may recognize, like on your SOLIDWORKS, you have that red light, green light icon. That's the regular rebuild, Control B. And what that Control Rebuild does is it just rebuilds or refreshes any features or any changes that were done within the model that SOLIDWORKS recognizes. The second thing is, so it's not going to rebuild any parts that haven't been touched, or it's not going to rebuild any parts that have gone through any change. So the rebuild times are going to be a lot faster compared to the Control Q forced rebuild, which is rebuilding the entire model. And that's why it's a function of this verification on rebuild option that's under the performance. Because if you're rebuilding the entire model or refreshing the entire assembly, of course, it's going to take a lot longer if you're rebuilding just the components that have undergone some sort of change. But the reason why we want this on is because, you know, again, going back to my tech support days, there have been situations where you are modeling or you're creating an assembly with that option off, and you may have edited or changed some element of the component, and a normal rebuild just didn't catch it. A normal rebuild just didn't catch the change, and in reality, you may have broken a mate, you may have broken some sort of reference, where a normal rebuild is just going to refresh the changes, but sometimes may not catch, you know, how that change is going to affect the overall model. So verification on rebuild is checking for the entire assembly or the entire model, and it has a better chance of catching those issues of any mates that are broken or any references that are broken as well. So, and then therefore, you'll be able to troubleshoot those issues early on, well before you actually set up your simulation study. Because if you if you create a brand new study with those issues or those issues that you haven't recognized yet, that can lead into some problems with either your mesh or the overall runtime. Right? So eventually, you want to clean up those issues as far as a mate or any references there. The cleaner the model is, the easier time the simulation solver is going to be. Right? So definitely make sure that that option's on. Nowadays, with our laptops, the performance is not really going to be an issue. Of course, if you're dealing with really large assemblies, you know, you may have to consider differently, but at the end of the day, I personally recommend always having that option on. Okay. So the next thing that I want to kind of talk about before, again, going into cleaning up the model is part management, file management, more specifically configurations. Right? Configurations for parts and assemblies. So going to SOLIDWORKS interface here, right? You may have created this model here, and it's a great looking model in my opinion. There's a lot of good details here, and you may need this level of detail to showcase or to demonstrate, you know, what the final design is going to be. All right, so your natural reaction, or at least if you're new to simulation or, you know, not really a big simulation user, your natural reaction is to throw this entire model into a simulation study or a CFD analysis if you're trying to run flow simulation, if you're trying to do some sort of thermal problem. But my recommendation here is to create a configuration that pertains only to your analysis, right? Because you don't want really to affect the quality of the final design, right? So what I mean by that is, you see in my configuration tab, I have a few of them. I have one that's called a full model, or it may be your default configuration, and then I created a simplified configuration, or you can call it like an FEA or CFD to differentiate or to let you know that that's actually pertaining to the actual analysis configuration. And what you can do with that is, you know, how configurations work or how you would utilize that. You can then start suppressing components in that specific configuration, and it will only affect that configuration. All right. But what if you wanted to clean up this model here where you wanted to get rid of some, you know, text features or get rid of some of those fasteners? Then you can link it to different versions of the parts as well. So how does that actually look like? How does that work? So what you want to do is, you can definitely create different configurations within the assembly, but if you want to locate it or, you know, link a specific configuration to a specific configuration of the part, you would have to create or open up that part individually. All right, and you see that this is what I have here. You know, in this case, I have the default model, or maybe I have different versions of that model and I create like a thicker fan, right? So you see that I created, just right-click on the configuration, add configuration. You can call this FEA, hit OK, and now whatever changes that you make here are only going to be affected in this configuration. So in this case, we can go into the model. Maybe I want to suppress some features All right, so if I suppress something here, right, I'm just suppressing some features that I may not need. And again, it's only affecting that specific configuration. So when I go into the thicker fan and go into my feature here, you see that it's unsuppressed in that configuration. So we're only affecting, whatever, that specific environment. If I wanted to adjust the fin thickness here, right? So it's a function of my sketch size here. If I edit the definition of that sketch, I can double click here, type in whatever value that I want, just make it an even 0.2. But before I hit OK, you need to be aware that what configuration or what this modification is going to affect. So because we are working with different configurations, you'll notice that we have this configuration icon. And I can click on the pull-down menu and say, I want to change this sketch parameter for either this configuration only, all configurations, or specifying configurations, if you had a lot of them, right? Picking and choosing, what configuration is going to affect. So if I select this configuration here, kind of rebuild that, hit OK, and back out of my feature, you see that my fins are a little bit thicker, and I can go back to my overall default, and you see my default fins are a lot thinner there, right? So all I'm really showing you is how configurations work, but now that you have multiple configurations within your part, you can go into your assembly, and you can select that component and then switch it to whatever version that you have. So if we were in, right now I'm working in the full model, let's say this was the actual model that I wanted to run that analysis, well, I can go into that configuration and then switch my part configuration to the FEA. Note that you have the same option at the assembly level. It's recognized, and I say, I want this specific assembly config to be linked to this part config, and you can say this configuration here, hit OK. All right, when we go back to the model, give me a sec here. All right, I think something got hidden here, but eventually what you'll be able to do is switch it to link it to that configuration. Sorry, I'm just going to reopen my SOLIDWORKS here. For some reason, it hid my body. Just give me a sec. All right. In the meantime, here I do recognize that there are some questions that are rolling in. I will try to get them during the presentation. If not, I'll just go ahead and answer them at the end. Yeah, I think what I ended up doing, I ended up suppressing a feature that I did not need. I think specifically the scale tool. So everything got messed up there. But let me bring it back here on my end. And pretty much what I'm getting at, though, is what I want you to kind of see is, configurations, calling out or creating different configurations at the component level, we'll be able to link them to specific assembly configurations and therefore clean up the model and get something, like this, right, where something that's very drastically different, right, but you see that in that simplified case, I have, a component here where maybe I'm utilizing my simulation, or I'm linking that chip to that simulation body. Again, that heat sink to maybe I just want it at the default for this one, right? So not only is it helping you with your simplified assembly, it's also helping you with being able to run different iterations of your component, right? So when you want to start running analysis on your different parts, right? So to recap on this here. Give me a sec. Okay, so all I really want you to get out of it is try not to run, a simulation study on the final design. You have a lot of capabilities where it will just manipulate to that new configuration, and you can avoid having to adjust that final design, all those hours that you spent modeling it, you can still keep that and then just adjust what you need in those different configs. All right. So sorry about it. It was a little choppy there and got a little messed up. But moving forward, we can then go into, the part simplification here. So one of the major things that I see, if I were to go into my SOLIDWORKS CAD model, you see that there is a lot of features that are a lot of details there that just weren't required. So going back to my full assembly, you see that there's a lot of actual text that are being extruded or created some sort of cut feature on the actual chips or on the actual components. And to be quite honest with you, a lot of that information or a lot of that detail is just not required, right? And you may end up running into some issues when you go into the mesh, because the mesh is gonna try to break down the model based on what you give it, right? So it's gonna try to refine the mesh and those small details there, and you may end up just getting a failed mesh because the mesh size is just way too big to try to account for this small level of detail. Right? And ultimately, those details are just not going to have an effect in your overall results, whether you're running a structural analysis or you're running a thermal problem. All you really need is the overall general shapes. And this is where configurations is really tied into that there, where, again, I can, open up this component here, creating a brand new or FVA configuration where you see all I did here was just suppress that cut extrude where it was on in my default. And it's just simple as that, right? Creating a new config and then suppressing the details that you don't necessarily need. All right, so that's one of the main things that I see here is, suppressing, and I want to emphasize on the word suppress. You do have the option to delete it, but then that's kind of destroying that feature for the entire final design. So whenever you're working with simulation, I always recommend suppressing, whether you're at the part level, the assembly level, or even suppressing features of your simulation. Always try to suppress, but in this case, remove or suppress any unnecessary features, unnecessary details in your specific part model itself. And then once you actually have your part, it's always a good idea to run a geometry check. Right? So if I were to look at that part again, actually, at the part level, in the Evaluate tab here, we have the Design Check. You can also find the check feature here under My Tools. If you scroll all the way down, under the Evaluate, there is the check option here as well, just in case you don't have it in the default command manager. But why this is important is because it checks the quality of your part, right? So let's say maybe you model this with some sort of surface modeling, where you just want to check to see if there's any invalid faces or edges or anything like that. You can run this check here, and what you end up getting is this menu where you can check for both solids and surface bodies. And the default options is usually okay, default being checked for invalid faces or edges. And this will actually pinpoint any areas where you may need to fix or reconstruct through some surface modeling technique. I will tell you, though, that if you're modeling these parts through SOLIDWORKS natively, the likelihood of you finding an issue here is probably going to be very small, right? Because it's all done within this interface. Usually when you start finding issues is when you're working with imported bodies or some generic file format, some dummy solid that you got from another CAD system or some other form there. But it's always a good idea to run a geometry check for your parts to make sure that the quality of your geometry is okay. All right, so if I run the check here, in this case there's no invalid faces or edges. If it did find any, you can actually click on the invalid face or edge and it'll pinpoint it with the yellow arrow where exactly the issue is. So really nice that we have that. Okay, the second part of this here is, I kind of mentioned it briefly, is working with imported bodies. So for those of you who are getting generic file formats, an IGES file, a step file, or a parasolid, and kind of side note there, if you are receiving files from another vendor, if you do have the option to specify what file format you want it in, I highly recommend choosing a Parasolid file as opposed to an IGES or a STEP. Reason being is because the kernel that's being used for a Parasolid file is the same as a native SOLIDWORKS part file. So what that means is the translation or converting from that Parasolid to something that SOLIDWORKS recognizes, it's going to be a little bit easier for it to understand, the actual geometry that you're importing. So you may have a easier time, a more successful chance of it opening without any real issues. But if you are working with imported bodies, you may have noticed that you get this, do you wish to run import diagnostics on this part? And hopefully you're always saying yes on this because it's running a check to make sure the quality of that geometry is okay. All right, so in doing so, going back to my assembly here, I'm going to open up this part, open up this component here, and oops, wrong one, sorry. Open up this component, and you see that this is actually an imported body, right? It didn't prompt me the import diagnostics message because I already received it and okayed it initially, but that doesn't mean that I don't have the option to run that import diagnostics again. So you see in my feature tree, I just have that imported feature, right? I don't have any of the feature history. It's kind of the nature of an imported part. But you see if I right-click on that imported body, you see that I have this import diagnostics. And when you select that, you see that in this case, it didn't find any faulty faces, gaps, or any weird edges of that geometry. So this part is actually okay. If it did find some, however, it would list them out in the appropriate box, whether you had a faulty face or a gap. But the nice thing about this tool is that you have these options here to attempt to heal all components or all the invalid issues, or specifically a face or a gap. And to be honest, in my experience, it does a pretty good job of figuring out those invalid faces and edges. Right? And what you want to see is this green note here. If for whatever reason you try to attempt to heal all the issues and it still can't fix a faulty face or a gap, you may have to utilize some sort of surfacing techniques. Right? Before I get into that, though, one thing to note about running the import diagnostics on the imported part, you also see that we have it on the Evaluate tab here. You will not have access to that import diagnostics if you add additional features to this. So what I mean by that, let's say if I add a sketch to this, convert the entity of this face here, right, add some sort of feature, hit OK. I just extended it. Notice that when I right-click on the import, I don't see that run import diagnostics in my Evaluate tab. You see it's grayed out. So you need to make sure you run that import diagnostics beforehand or before you add any additional features. So if I were to delete this here, and then delete my sketch, you see that when I right-click, I get that option again. Okay? So we run the import diagnostics, everything's okay, but you're dealing with an imported body, right? And I just told you that I don't want to see any of these issues or see any of those cut faces there, or maybe it did find some sort of invalid face on this fillet. Even though visually it looks okay, you may need to reconstruct that fillet. So I'm going to show you a few techniques that we have available to be able to fix that. So I also want to point out as well that when I turn on my SOLIDWORKS simulation option, in SOLIDWORKS 2016, they added a new tab in my command manager where this analysis preparation tab here. This analysis preparation tab includes features, not necessarily no new features, but features that you had access to already, but they're the most common features where you can utilize to fix up or simplify, clean up the model before you send it off to a simulation study. So it's kind of nice that they filter that out for you. A lot of the times you'll see that when you're trying to fix an imported part, you are utilizing surface modeling techniques, which is why there's a lot of surfacing features in this. But just be aware that you can kind of turn that on and kind of see what the features you could use. In this case, what I want to do is, maybe I want to reconstruct this face, or delete this this top face here. What I can first do is, I can measure out what the distance of from my top face to this edge here, and we're looking at, let's make some units that make sense here in terms of millimeters. All right, hit OK. And you see it's about 1 millimeter high, so kind of make a mental note of that. And I can go into my surfacing technique, or my surfacing options here in my command manager, and I can say, or what I can choose is to delete face. I can delete this face here, hit OK. And you see that once you delete a face, it automatically converts the entire model into surfacing here. So you see that we have the face number 1, face number 2 here, and ultimately I don't want those faces, so I can right click and say delete keep body. I just want to delete that body there. And you see it gets rid of that. And then what I can do is I can go back to my surfacing tools. I can extend my surface here, just select my geometry. I want to bump that up to 1 millimeter because that's how high it was. Hit OK. Then I can make like a planar face. Select that face there. And then since we're working with surfacing, we have more than one surface. We need to knit those surfaces together. And then hit OK. And then what I can do from that is I can go into a traditional fillet tool, select my fillet there. Maybe I want that to be 1 millimeter again, or adjust it now to whatever degree you want. And now you have the overall general shape, still a surface body. We can then go into our thicken tool, and then you see that I can select that face or select that surface. And then we have the option, SOLIDWORKS recognizes that there is an enclosed volume, and I don't want that component necessarily to be hollow. I want it to be an entire volume or a solid part. I can select that option there, hit OK, and you see that I've reconstructed that face utilizing these surface techniques. And these are going to be the same techniques that you utilize if you need to repair an invalid face or an invalid edge or gap that the import diagnostics wasn't able to fix on its own, right? So, of course, this is a really simplified case, but these are the overall techniques or the overall tools or how we would actually approach this problem. Of course, if you have a more complex issue, the servicing process is going to be a little bit more involved, but you can at least know that you can manipulate this imported body and get rid of those features. The other thing that I want to discuss here in regards to imported body is direct editing, right? Being able to, you may have heard of FeatureWorks. FeatureWorks is a tool that you can run and kind of reverse engineer how that component is actually being made, but sometimes that check doesn't necessarily work. So you do have the option to kind of edit specific features on a feature-by-feature level. So what I mean by that is, let's say I'm okay with, I'm just going to ignore that there is that extruded face there, but I want to adjust the size or maybe even get rid of that fillet. Well, what I can actually do is I can right-click on that fillet, and I can say Edit Feature, and what it actually does is create that fillet feature option there, and it's something that I can edit and adjust my size, right? And technically, it's something that I can get rid of as well in terms of getting rid of that feature, right? So here are some other editing or direct editing techniques that you can utilize. It's a lot easier when you're editing the feature on a simplified case, like in this case, a fillet. If you have holes, you can right-click on the hole, and it will create a hole wizard as well, so you can adjust those components as well. So you can directly edit on a feature-by-feature level, and it'll hopefully create that feature where it's editable, or you can just get rid of it, right? The other thing that I want to discuss here is if you look at the Analysis Preparation tab, you see that we have this Move Face, feature here. All right, so what if I wanted to extend the length of this component? Obviously, we can utilize normal features like create a sketch on that and then do some sort of extrude. For a more complex setting, you can utilize that move face. And what that move face does is I can select that face there and say I want to extend it, right? So I can make it bigger, make it longer, or I can do it on the opposite end here, select this face and do the same thing, or should be able to extend that there, right? Or should be able to kind of make it, extend the location or whatever it may be. But the best example here that I can give you for now is kind of manipulating that imported body, extending the faces with this move face command. All right, so it's intended there for working with, manipulating with imported parts. Okay, so again, this is what we have here. This is what we can utilize, or kind of the highlights of what you need to look at a part level. When we graduate to a more complex assembly, there's a lot of things that we can look into as well. The first thing that I want to take a look at is this cleanup mate warnings or issues by fixing part components. So if I go into my actual assembly again and go into my full model here, let it just kind of refresh here. You see that when I go into that configuration, there's a few errors that are being applied there. And when you look at the overall feature tree, there's a few warnings, few warnings there on the actual part, a few issues with the overall mates as well. But keep in mind that if the end goal is for you to send this to a simulation study or a CFD analysis, the mates are not necessarily going to be utilized in anything in regards to that analysis. They're only really used for positioning only. So what you can do is you can suppress all these mates. And do a shift select here, right click on that, say suppress. Suppresses all those mates. Be careful though, because at this point it's getting, you can easily move a component and mess up the position. But in order to avoid that, you can then select all your components, right click on them, and select this, or actually let me do these first ones here. If I select these here, I can right click. I have this option to fix. And what that's doing, it's restraining the model at that specific position. And again, I can do it for this configuration only. You see that my symbol goes from a minus sign to just an F, meaning that it's fixed. And right now, we are fixing, again, the position of those components. So it's a nice way for you to clean up those warnings, clean up those issues with the mates, and then really securing the position of those components. Right? So it's a nice technique, a technique that our simulation services utilize quite a bit to make sure that we are restraining the components at that specific position. Right? And you see that I went from something that was filled with warnings and issues to something that's a lot cleaner, and it just makes your life easier in terms of troubleshooting any potential problems with the model in relation to simulation. Okay, so that's one thing that one technique that we can utilize when working with assemblies. And the other thing is, just overall suppressing components that you may not need. So, for instance, suppressing details or level of details here that is just not necessary. These little fins here, or any toolbox components as well. Right? Ultimately, those things are just not going to play a huge role in my analysis, depending on what I'm running, of course. Right? So if I want to suppress those fasteners, assuming that you have toolbox components and you have a lot of toolbox components in your assembly, instead of having to dig through your feature tree and right-clicking and suppressing, you do have the option here to, in your little cursor icon here, you may have noticed that you've always had this pull-down menu. When you click on that pull-down menu, it's a way for you to select or filter out specific components as far as highlighting them. One of them being select toolbox. So when I select toolbox, you see it highlighted these two components here. And then at that point, what I can do is I can hold control on my keyboard, right click, and then just simply suppress them. So if you're working with toolbox components, have that add-in, then you can turn on that filter to easily select all those components there and then just suppress them. Again, suppressing components that are just not needed. So what happened with these guys? How come these guys are not toolbox? Well, they were considered. Maybe you went into McMaster, you downloaded those part files, and they're just seen as traditional part files. Well, what can you do then? Do I have to still kind of manually filter out, find those components? Well, not necessarily. What you can actually do is find where those components are in the tree, and for these set of components, I can highlight all these and right-click and say Save Selection Set. So this is a new feature that they introduced in 2015, where when I go to Save Selection Set, it throws it into my Selection Set folder, and you see I had a couple here, and I can click on the selection sets, and it automatically selects all those components. And then what I can do is, again, hold Control on my keyboard, and then right-click. It'll easily find them in the graphics area, and then we can suppress those components as well. All right, so if you don't have if you don't have Toolbox, you can utilize that selection set option, or either way, if you're using non-Toolbox components, selection sets is a good tool to utilize to easily find where those components are at a later time. Right? But again, ultimately, cleaning up your assembly to get rid of components that are just not needed to run your simulation study. Okay. Going back on the list here, in the assembly level, you do have the option to run a geometry check. It's located again under Tools, Evaluate, Check. I do recommend, however, to run the geometry check on the part individually, because I have seen it where if we run the geometry check at the assembly level, sometimes it doesn't catch some of the issues, specifically more so if the parts that have the issues are in like a subassembly. Sometimes it doesn't catch it. Either way, if there are issues with those parts, you would need to fix them at the part level anyway. So I always recommend literally going down the feature tree of the assembly, right-clicking on the component, opening them individually, and running that geometry check. Okay. The other thing that we have here in relation to toolbox components, if you have that add-in enabled, what you can do is when you're actually in, so let me unsuppress those toolbox components, unsuppress those back, and focusing on these two parts here, those are the only ones that are classified as toolbox. If you create a brand new study, you will have the option here to convert toolbox fasteners to bolt connectors. Right? So when you're utilizing fasteners, usually the intention or what the point of those components are is just to restrain, in this case, the PCB to the actual casing, or attaching it or restraining it somehow. So we don't necessarily need that physical geometry, but we may need the elements of how it's restrained to get accurate results. So in utilizing Toolbox, we have the option here to select this Convert Toolbox Fasteners. If I hit OK, it's going to run a check on where those toolbox components are, and then you see that it found those two components. You see that we kind of get the silhouette of what those components are, and it says that it successfully converted it to a bolt connector. Right? When I hit OK, what it actually does is creates this connection folder here, and you see that it created these virtual toolbox, or these virtual bolt connectors. If I edit one of them, all it's doing is, again, simulation is in the environment of SOLIDWORKS CAD. So what that means is it's going to recognize, it understands that those components already have properties. You've already defined where the location of those are, what the type of fastener it is, and you see that it automatically selected that this was a standard or counterbore screw. It automatically selected the references that it needed, the correct size of head and the shank, and it automatically created or specified what the strength data is and the preload for that specific component. Again, all that information is already integrated within your toolbox library. Why go through the work again and have to redefine it when it's already integrated within SOLIDWORKS. So you can definitely utilize that option there to automatically convert it. If you don't have the luxury of having Toolbox, you do have the option here to create bolt connectors and pretty much all these virtual components here to get the properties or how it's going to behave in a simulation study, but not necessarily have to have the physical component. Right, so if I go into the bolt connector, you're just choosing the type of bolt, choosing the reference on the physical geometry, and we can have that type of restraint, that type of behavior as it would in real life. Okay, so definitely take advantage of that when applicable. And then one of the most important things here that we have is checking for interference. This is very important because when we go into a simulation study, if there was any interference and we try to mesh and run, it's just not going to allow you. Simulation will not give you the option to run if it detects any interferences here. So if I go into my new configuration here, maybe you cleaned it up so much to the point where you ended up getting this, right? So you removed all the toolbox components, you removed all those details on the individual parts, and now you're ready to run that interference check. Under the Evaluate tab, we can run interference detection. One thing to note about this menu, there are 3 options that I recommend having on. One of them is the default one, make interference parts transparent. This is what's actually going to show you where those parts are that have the interference. And also turn on include multi-body part interference. If you're working with multi-body parts, in a single part file you have more than one geometry, there may be some interferences there that may cause some issues. So you want to make sure you turn on that alert. And then you want to make sure you turn on show ignored interferences. So any interferences that you may have ignored previously, just make sure you turn that on as well. And then when you hit select calculate here, you see that it found a bit, right? Reason being, in this case, I extended that model. I can fix that very easily. Going down the list here, you see that there's a lot of, where that chip's located, there's a lot of interference. It looks like it's digging into the PCB. So there's a couple ways for you to approach this. For one thing, this is great that we were able to catch this before going into our simulation study. So now that we're aware that, maybe the length or the extrusion here is a little bit too much, or it's going into the model, right? So if I run that calculation again, you see that it's just overlapping just a little bit. But that little issue there will cause a problem when going into our simulation study. All right, so how do we fix that? The easiest way is most likely there is a coincident mate that's mating the faces of those chip or of the chip to the actual PCB. So you can just adjust your mate and then get rid of that interference. There may be situations though, however, where that's just not really feasible. Well, what you can do is you can actually physically remove the shared volume that those 2 components are having within that interference and actually physically cut that material off of the geometry. Be careful with that because you are affecting the overall features of the part, but you're at least getting rid of that issue. So that being said, how does that work or how can we do that? We can do that by utilizing the cavity feature tool that's available within your parts, within your single components. So it's easier to do it in context of the assembly. So if this is the component that I want to remove material from, this is going to be the part that I actually edit that component. So if I right-click on that component and say edit part, we're now active in the part, or inside the assembly, we now turned on that component, and I can go into Tool or Insert, Features, Cavity, and when I go into the cavity, what it's asking for me here is selecting the component that's almost like the cutting tool, the component that's going to remove that material. In this case, it's going to be the PCB, and when I hit OK, what it actually did here was remove that shared volume that those 2 components have, where the PCB still remains flat, and it just cut away the materials of that chip. So now when I exit out of my part here and go into my interference detection, and nothing's really changed, still running it for the entire assembly and hit calculate, Now the only one that I really see is this component here, but all the other ones went away, right? So through that cavity feature, it removed that shared volume, and it's affecting the overall amount of material that's interfering into that PCB, right? And it is a feature that you can control. It is a feature that you can edit. So what I mean by that is if I were to find that component in my feature tree, right, I can scroll down and you see that I have that cavity feature with that arrow, meaning that that feature was done in context of the assembly. So there is some relationship there that that feature was created utilizing another component. All right, so that's a very common feature to utilize to fix some of those problems where those interfering bodies may not be easily fixed or removed by maybe adjusting the mate. Right. So that's pretty much what I had here for simplifying an assembly, and really what I had for how to approach a part and an assembly overall. Again, like I mentioned, there's a variety of different ways of how to clean up a model, how to fix a part, but these are your most basic, your most common tools that you will utilize in any scenario, really. And the more complex the problem is, of course, the more involved it's going to be. But at least you have an idea of what to look out for and how to approach these problems on your own end. Okay, and just to recap again, some general tips for simulation. You know, always start simple as possible and then build complexity to the model, right? It's just going to make your life a lot easier and troubleshooting any issues that you may have, right? So always start with just the general shapes. You know, get rid of any details that are just not necessary, asking yourself ultimately, what are you trying to test and learn from the analysis, and then get rid of those components that may have an effect on that, right? And the other thing that we can do as well is any fasteners, any toolbox components, you can replace them with virtual bolts, right? If you still need to restrain them somehow due to, you know, how the fastener is going to work in real life, we have a lot of virtual techniques or virtual tools to replace those physical components. And then lastly, and I didn't really talk about this, not really the point necessarily in this webinar, but in the theme of simplifying your problem, maybe utilize shell or beam mesh. You know, right now, if you model with normal SOLIDWORKS features, you're going to get a solid mesh. You know, that may be an issue when you're running with frame-like components, if you're, you know, running analysis on a frame, or very thin components like sheet metal parts. Using shells and beams will make your life a lot easier in terms of the complexity of the overall problem. All right. So those are some general tips for simulation. And then lastly, you know, to get more information on how to simplify a problem or kind of looking at these techniques, this webinar will be posted on our website. For those of you who are, you know, requesting the PowerPoint, that is an option as well. But there are a lot of different options that we can utilize, like going to our YouTube channel or our website itself, have links to videos that, you know, kind of go into these specific topics. But of course, if you're on subscription, then you can go and reach out to our technical support team. You know, me being part of that as well, I've had multiple conversations on cleaning up models or, you know, reasons why you're running into issues with your mesh or your overall study. A lot of them pertain to the issues that I presented in this webinar. And then, of course, we can go into our training, right? If you've ever taken training with me specifically, I am always bringing up simplifying models, different techniques there, kind of trying to introduce elements that are not necessarily introduced in the actual manual in itself. And then we understand that the process of approaching a problem, you know, what the best case scenarios are, what are the, you know, best practices for approaching this problem. You know, we at Hawkridge, we do this every day. So you can utilize our mentoring or consulting services or as well. Mentoring where you may have taken our training, but now you want to focus what you learn on a specific project. We'll be able to work one-on-one with you, guide you in the how to approach a problem, what the best practices are. Or if you don't have the tools or if you just want us to do it, we can do that through our consulting offerings as well. Okay, so definitely let me know if you have any questions about that. Again, just want to point out as well, we do these webinars every Wednesday. We have some other webinars coming up for this month. Next week, we're going to be talking about what's new 2017 for assemblies. The week after that, if you're interested in knowing what nesting works is or, you know, what's new about it, That's going to be on March 22nd, and then end the month with being able to utilize Composer and our new rendering tool, Visualize, to create marketing content, and that's what we'll finish off the month. So again, I just want to thank you for your time there. I know I ran a little bit over there, but if you have any questions, any sales-related questions, feel free to contact your local account representative. If you have any technical questions or technical support issues, go ahead and reach out to them as well. I'm going to stay online for a few minutes to answer a few questions that came up on the chat. But if I don't hear from you there, hopefully you enjoyed the presentation. Again, this will be posted on our website, and have a good day.